Quickly. All right, everyone. You're going to finish off 3.3. It's actually more of a little fun thing. It's not going to be as complex at all as what we were doing before, but because it is a reality, I do want to cover it. This will actually segue into our lesson in 3.6 because 3.6 being extra. The textbook, I don't know why, it does not talk about wholes. Yes, wholes. Do you remember in our previous lesson? Remember in our previous lesson, we did a timeline or a number line, and then we had a little empty hole when we were talking about intervals. Do you remember that? And there are other examples where I had like a solid line, and then I had an arrow going this way. And there was another example where there was a solid line, there was a hole, and then everything included in between, we just label it like that. So what do we do when we're in a 2D environment and we have a hole in a graph? Well, first, let's take a look at what that looks like in an equation. The function that's given to us is f of x equals x plus 3 over negative 2x minus 6. It may be in your best interest to make your lives easier by factoring out. Before we do anything, can we first talk about restrictions, please? What is the one value we cannot have for this function? Yep. Yeah, because the denominator will turn into negative 3 if that happens. Okay. But wait a minute. What do we see here? Don't say cancel. We divide out and they become ones. So the final answer is f of x equals negative half. What the heck does that mean? Yeah. F of x, it means y equals negative half no matter what. No matter what x I give you, y equals negative half. In other words, let's pretend, you know, 2 boxes, that's a negative 1. 2 boxes, that's a negative 2. 2 boxes, that's a negative 3. My line is going to be just like that. Except I forgot something. Yeah, x cannot be negative 1, negative 2, negative 3. So this function, yes, it could have asymptotes. Yes, it could have vertical, horizontal. It could have x-intercept. It could have a whole bunch of stuff. But when we divide it all out, we realize it doesn't need any of that. It's essentially it's going to look exactly like a horizontal line. But because the original equation, original function had a restriction, we still need to respect that. We still need to show that exists. So we do that by drawing a hole at negative 3. The arrow, the line goes like this. So this is f of x. That is a hole. In other words, what is a hole? Hole is a factor You could think about it like that. A hole is essentially a factor that was divided out. It's a 0 that was divided out. Okay, not seen in a simplified equation. Yes.
So, when we go for
No, it can go through. Yeah. Locally, you'll see when we get to 3.6, there's a lot of things that you'll be exposed to. You'll see it's possible. Yes, Yusuf.
What if the value that was acted out like
Uh-huh.
that be
Yeah, again, depending on what factor divided out, right? That would tell me where the hole is.
anything?
Anything could be a hole as long as it was there as a restriction, but not there in the equation. It was there as a restriction in the original function, but when you simplified it, you see that the simplified graph is just something else.
Oh, so it's just a restriction.
It's a restriction, but not a vertical asymptote. You see what I'm saying? If we left it like that, you would be inclined to say that's a vertical asymptote. Would you agree? The denominator is equal to 0. However, when we simplified it, that x plus 3 actually gets canceled out. It will not affect the function at all. It's as if it's not even there. So when we draw this curve, it'll look like this. However, the restriction is still true because take a look. I think a lot of people are showing me blank faces. Let me go to Desmos. If I were to plug in x equals 1, x equals 2, x equals 3, x equals 4, and graph everything, this function and that function will be exactly the same. Let me show you. F of, so y is equal to, bracket, x plus 3, bracket, negative 2x minus 6. Notice how if this was the case, would the x plus 3 be factored out? No. So that's why we have a 0, we have intercepts, we have vertical asymptotes, whatever. But if I plug this in, negative 6, all of a sudden that x plus 3 is reduced to 1. And so we have a straight line. And if I zoom in to the 3, whoa, there's a hole. It's undefined. There's no number there.
Does that mean sometimes you can factor out something of the denominator?
So in fact, actually, I encourage you to factor everything out possible. Just divide it all out so that you can graph a simpler function. What's the simpler function in this case? Isn't it a lot easier to just graph that? I like to think so. So why not just graph a straight line instead of trying to calculate all the asymptotes for this? But because I'm graphing this and not that, I have to respect the fact that the denominator could still technically have been a 0 with negative 3. So that's the only value that is not allowed. It's a hole. Yes. Yeah. Simplify it, graph a simplified function, because graphing a simplified function will be easier for you, but go back to the original and tell me what the restriction is. This is just like grade 11 rational expressions. In the very first chapter, you were supposed to simplify a whole bunch of stuff when you were multiplying or dividing. But when you state restrictions, you always go back to the original. Do you remember that? Or am I talking crazy? Let me try to explain what I mean. I don't want you to think I'm talking crazy. Here's an example. Do you remember, this is the very first unit in grade 11. Grade 11s right now, they sort of finished it last week. Do you remember if I had x over 3, like x plus 2 times or divided by x plus 6 over x plus 2? What are the restrictions? X cannot be a negative 2. X cannot be a negative 2. And you can't divide by a 0. So X also can't be a negative 6. Do you remember that? No? Please, please. This, and this all are restrictions. So when you solve it though, when you solve it, x plus 3, x plus 2 multiplied by x plus 2, x plus 6, cross, cross, I get x plus 3 over x plus 6. And it's so much simpler to graph this instead of this. They're equal, they're the exact same thing, but it's so much easier to graph a simplified equation. However, x minus 6 and x minus 2 are still a no-go. You cannot graph that on here. So you draw them as wholes. That was grade 11. Yes. No, negative. The answers that I put on Brightspace, I made a mistake. I put everything with the reverse sign. So that's my fault if that's what you're looking at. The true answer is it can't be a negative. Yes. Okay. I wanted to go straight into that because I said it was a good segue. But I feel like example 3 is just an interesting question that you can do. This would be like a simpler application question. Example 3. Yeah. Okay. Find the values of m and n if the vertical asymptote is 6 and I have an x-intercept at 5. You're going backwards. I'll give you 30 seconds. Just think about it. Yep. Because it should be automatic. There's actually no real big calculation involved. It's just, okay, that means this. And x-intercept, okay, that means that. If you remember that the vertical asymptote means the denominator is approaching a 0. The vertical asymptote is directly related to the denominator. A vertical asymptote at 6 means 2 minus n. When x equals a 6, the denominator became a 0. Okay. The vertical asymptote is from when you get a 0 in the denominator. So what is n? Well, n must be 1 over 3. So you might be surprised if I give you a question like this. It might seem hard on a test, but it's literally one step each. This wouldn't be more than 2 T questions. I just gave you an example question. I'm not saying it's going to be on your. Oh, you mean this particular material? Well, this is 3.3. So next, x-intercept means my y value is a 0. How do you make this entire value, this entire fraction a 0? Yeah. So when I say x-intercept is a 5, it means 7x minus m becomes a 0 when the x value is a 5. There. That's it. Yes. Right. Yeah, no, it's fine. Well, the question says find the values of m and n. So as long as you found it, you're good. In my answer key, I tried to put it together, but it wasn't necessary. Okay. So, so going back, okay, this was just like a little plug into all of our vertical asymptote and whatever calculations. Melody asked before, what the heck do you do if you have a denominator that's bigger, like, they're trying to simplify it in terms of holes? Let me show you what the holes might look like. And I think maybe I'll do oblique asymptotes tomorrow. We'll just finish off holes today. Okay? So don't do anything past the first. You're not even back. Yeah. Don't flip open this package, okay? Don't flip open this package. Just look at the front. All right. I know you're tired. We're almost there. This is going to be my last example, okay? Sure. Let me help with this part though. There you go. And I will pause this recording. Okay, pause the video if you need to and continue working on as you see fit. I'm going to slowly write out the answers in hopes that you will join me wherever you are at this point. Please also note that I fixed this curve. It's supposed to be x squared plus 2x, not minus 2x. Sorry about that. You might want to pause the video again and try, okay? And then I am going to divide this, becomes 1 and 1. So my actual equation is 3. There you go. Okay, domain. Oh, too large. Domain. That's a hole. This is vertical asymptote. Intercepts. For the y-int, f of 0 is going to be 3/4. For x-int, f of x will never equal a 0, therefore, no x-intercept. di. Now, time for asymptotes. VA, we've already established, is equal to -4. Horizontal asymptote is essentially the end behavior as I approach infinity. Well, as x approaches positive infinity, f of x is going to be 3/infinity. It's essentially going to be 0 from the positive side. X going to -infinity, f of x is going to be 3/-infinity, which is basically 0, but from the negative side. And then chart. Lucky me, I only have to plug in my vertical asymptote and the x-intercepts. I have a vertical asymptote, but no x-intercepts. As well, from my final function, the simplified function, the only term that can change signs is that one. So whatever that sign is going to be, ooh, what happened? Whatever that sign is going to be, it's still recording? Okay.
Kim,
Yes.
does that mean in a restriction? Realize one of them is the fault. We don't use it as like in the chart.
Yes. So everything was erased for whatever reason. I don't know why. I'm gonna have to do this again, but I hope you got something out of that. So f of x is essentially going to be 3 over x plus 4. My intercept was 0, 3 over 4. And for x-intercept, there's none. For asymptote, vertical asymptote is negative 4. For horizontal asymptote, it's going to approach 0 from the positive end and 0 from the negative end. And then the chart was where I was at. Negative 4, x plus 4. So question, Yusuf, you were asking, what was it?
So the restriction, usually, if you get two restrictions, that means there's vertical asymptote.
Yeah, essentially. But in this particular case, remember, one of the restrictions is actually a hole.
It's just valid.
What you are going to graph will look like this. Because it's simplified, it's not going to have two vertical asymptotes. It's going to look like that fraction, which has one vertical asymptote.
So the
Right here.
whole is really kind of
X equals positive 2 is a hole. In other words, look at this function. Is positive 2 a special number in this new function? No. So you draw this as if nothing happened, but you have to go back and remember where this new function came from. The original, the absolute original had a restriction of x cannot be a 2. So you still have to make that known in our simplified function. So this is smaller, that's a negative. This is larger, that's a positive. So the function is negative and positive, and this is my vertical asymptote. And if I were to graph it, my asymptote is at negative 4. And then my horizontal asymptote, it approaches a 0. On the positive side, it's going to be above the asymptote. On the negative sign, it will be below the asymptote. As I approach the vertical asymptote, it's going to remain a negative. So I know it's going to do this. And then right after I pass the vertical asymptote, it sort of teleports to the positive side. My y-intercept is a 0.75 or 3/4. And I have no x-intercepts, which makes sense. There you go. Good point. What about the hole? This would be perfect, except you forgot that where the function came from. The original function said that the x value of 2 is not allowed. There it is. I think you get the point. That's a boat.
kind of monster.
That's a shark.
They are comfortable.
And that's a hole. Get it? No? Forget it. Hate you all.
Oh, yes.
Okay, and that's it. So this is holes. When you draw a hole, it actually doesn't really show up as it doesn't change the shape. It only creates a little tiny blank in the simplified function. So one step that you just have to add into everything we've done so far is simplify, factor out, see if there's any brackets you can divide out. And then move on with all the other steps with D, I, A, C, so on. Yes, Roman. Ultimately, you can do whatever you'd like. As long as you don't make a mistake. The chart is there to make your life easier and give you confirmation when you're graphing. There shouldn't be two numbers up here. There's only one number. You shouldn't have to test 3 different numbers. You only have to test a number smaller than -4 and test a number bigger than -4. Remember, the whole point of this is to put in numbers where you see a sign change. The whole, as you can see, doesn't make the function go underneath the x-axis. Beta? Sure, I'm gonna have to clear this. But if you recall, if I factor this, this was 3x minus 2 over bracket x minus 2 and x plus 4. So what are the x values that we are not allowed to have? Yeah, that's all it was. Because when you cancel this out, the one that canceled out, it's like it's not there, but we need to remember it was there. Yeah. Yes. Yes. Okay, so for everyone else, if you want to, it was just a good example to try to check out a hole. My homework for you is from 3.3, okay, all the practice questions that I set up in that sheet, try it. And if you do have time, try out example 2, because that is still a question about holes. Okay. So go back to 3.3, practice your DIAC. In 3.6, that's a intense example of holes. Okay. And let's see, minus minus, that gets crosses out. Minus 2. 1 over. Oh, that's going to be interesting. We'll see if you can. This is, consider it a challenge. Okay. And I will stop this video here. Good luck.